Thanks for coming and attending this. My name is Vikas Bhatia, and I am the head of product for Azure Confidential Computing. Today, we'll be talking about applying confidential computing with Intel SGX in regulated industries. So thank you for joining us. I have been in Microsoft for 13 years, and I have done stints all over the place in Windows Developer Platform, in game streaming, Xbox One, the C++ compiler. But today, let's talk about confidential computing. Microsoft spends over $1 billion per year on cybersecurity, and much of that goes into making Azure the most trusted platform. From strict data center security, ensuring data privacy, encrypting data at rest and in transit, novel uses of machine learning for threat detection, and the use of stringent operational software development lifecycle controls, Azure represents the cutting edge of cloud security and privacy. Azure Confidential Computing offers a collection of features and services that offers a protection that to date has been missing from the public clouds, which is encryption of data in use. This means that data can be processed in the cloud with the assurance that it is always under customer control, your control. Our North Star here is to constantly lessen the need for trust in Microsoft operationally, as well as your own operators, your own customer operators, and enable those end-to-end confidential scenarios across privacy and sensitive workloads that we see so often in regulated industries, and also workloads such as multi-party data sharing. We have been working very closely with Intel on SGX, which stands for Software Guard Extensions, which provides the strongest isolation model that customers can use today. With that said, I would like to thank our panelists who've joined us for this conversation. We have Andrew Tauhert from XPRIZE. We have Michael Shalov from Fireblocks, Sarah Drakely from Mobilecoin, and Steve Svetko from Novarad. Thank you so much for joining us today. I'm happy that this will be a great conversation. So with that, let me introduce our first panelist, Sarah from Mobilecoin. Sarah?
Hi, thanks, Vikas. I'm Sarah Drakely Hall, an engineering manager at Mobilecoin. We are building a cryptocurrency to provide fast, private payments for everyone. Vikas, it's been great working with you and the Azure team, and I want to say thank you to Microsoft for having me, and thank you to the audience at home for tuning in. Let's talk about Mobilecoin and the problems that we're solving. As a decentralized payment system, Mobilecoin Payment Processing Network consists of multiple nodes who are operated by a series of third-party actors. These nodes all have to come to agreement on whether a transaction is valid or not. Our payment processing network is open membership, so anyone can join and offer Mobilecoin payments. With Intel's SGX, we can be sure that none of these processing nodes have been corrupted, which, in the worst case, if enough nodes were compromised, we could lose all the money in the network or allow someone to print money arbitrarily. To make our payment system resilient against this type of failure, as well as secure and private, we created a layered defense. We use Intel's SGX because it provides integrity via remote attestation, a special cryptographic handshake which proves that the nodes that you're talking to are running the exact audited open source software expected by the network. The next layer is the consensus protocol that we developed to enable the payment processors to come to rapid agreement on the validity of transactions. The layer below that is that the contents of the transactions are encrypted end-to-end, so that only the sender and receiver know that a transaction occurred and all other user data is obscured. Last, SGX provides a layer of confidentiality so that transaction validation happens in encrypted RAM. And even if you have access to the machine itself, you can't see any information about the transaction or the validation. Through remote confidential compute, like what Microsoft Azure offers, we process payments at scale while leveraging the integrity and confidentiality of Intel's SGX Secure Enclave. Until now, there hasn't been a fast, private, decentralized payment system that works on your mobile device. We're changing that. When you use a mobile messaging system, you have the expectation of privacy. When you use other payment systems, they're fast, but your data is being sold. When I worked in finance previously, we bought credit card data. Your payment activity is available for purchase. At Mobilecoin, we believe in user privacy first, that users should have control over sharing their own data. In a private messaging app, for example, in Signal, messaging is fast and users feel secure because it's open source, it's end-to-end encrypted, so users know that it's private. Even Signal Messenger provably cannot see the contents of user messages. Mobilecoin's the same way. We, as well as the third-party network operators, see only cryptographic noise instead of any user data. We're a pre-launch cryptocurrency currently running our testnet. Upon launch, we will be one of the largest consumer-facing SGX services. Try our testnet and review our open source software at our GitHub, Mobilecoin Official. Also check out our case study featured by Microsoft at the URL on the slide. Thanks, Vikas.
That's awesome. Thank you, Sarah. These are the key innovations that will move our entire industry forward. That sounds super awesome. So with that, let me introduce Michael from Fireblocks. Michael.
Thanks, Vikas, and thank you for having me on this panel. Very exciting. So I'm Michael Shala. I'm the CEO and co-founder of Fireblocks. My background is actually in cybersecurity, so spent the last 20 years in the cybersecurity space through service in the Israeli Cyber Command. Started my previous company that was sold to Checkpoint, led the mobile security and cloud security for Checkpoint for about 3 years, and we started Fireblocks about 2 years ago. Our goal at Fireblocks is basically to provide an enterprise-grade, highly secure platform for financial institutions that are dealing with blockchain technologies, digital assets, and cryptocurrencies. So since we launched our platform about a year ago when we came out of stealth mode, we had really an exponential growth. We currently have over 100 institutional customers that are using our platform, all the big brand names in our space and in global finance. We've transferred over $100 billion worth of digital assets through our platform. And currently, basically in the last couple of months or the last quarters, we basically were doubling this volume quarter over quarter. And currently, we are transferring about $20 billion per quarter, right? Per month. Our customers are actually the financial institutions that we all familiar with, right? So those are the banks, the big banks, custodians, brokers, lending providers, and some specific technology and commercial platform that offer services in the cryptocurrency space. Now, clearly, with whom of you are familiar with digital assets and cryptocurrencies, it's sort of well known that a huge amount of cryptocurrency was stolen over the last several years. Actually, the number is 15 billion. And for us, really the challenge and basically the goal is to provide an infrastructure that allows our customers to securely store those assets and transfer those assets across the ecosystem. And really, our customers basically rely on us to provide a highly secure and very scalable platform that allows them to do it. So when we approach the technology challenge of actually solving really probably one of the most difficult problems around blockchain, we had to figure out how to combine security with speed, security with efficiency, and security with regulation. And we'll talk about it a bit later. And in terms of how we find a solution for that, we actually approach it in a very sort of defense in depth type of approach, where we layered multiple technologies one on top of the other. So we're using multi-party computation to actually distribute the private key, but every share of that private key is actually running in Intel SGX and protected using the technology that we've engineered. And we're actually using Azure Confidential Cloud Computing to host the vast majority of our infrastructure, but we're also able to distribute it across availability zones and other cloud providers as well for redundancy. So from our standpoint, our ability to rely on Intel SGX and the ability to rely on Azure Confidential Cloud Computing was really a key to our success and to the scale that we were able to achieve in a very short period of time.
That is awesome. Thanks for that, Michael. This is so exciting. I'm so happy to see the growth that you've just seen in such a short time. And the way SGX is helping you. So I'm super excited to see the journey that you've been on so far. With that, I'd like to introduce Andrew from XPRIZE. Andrew?
Thank you, Vikas, and thank you to Microsoft and Intel for working with us on this project. So I'm Andrew Towert, VP of Partnerships and Strategic Initiatives at XPRIZE. In case you're not familiar, XPRI is a bit different from probably others that you see on here. Is we're a nonprofit with over 25 years history in incentivizing crowds to solve major world problems, usually along the lines of equity, environment, and exploration, through competition. Large-scale competitions typically run multiple years and have large incentives to drive innovation. But what brings me here today is really two initiatives that kind of came together. One is our data collaborative. So a few years back, we found that there was an increased dependency on data sciences, AI and ML to be able to develop the solutions that are associated with our prizes. And there's a huge amount of value that comes out of our prizes because very often they are in and of themselves activities which generate large value data. So we started that a couple of years ago, incidentally built on Azure. And we've been running that horizontally across all of our programs within the XPRIZE Foundation. Then when the pandemic hit, XPRIZE thought about how could we respond to the pandemic, and one of our strengths is convening, is solution development, is competition. So we partnered with Anthem Health and we launched the XPRIZE Pandemic Alliance. Today, that's 80 some odd corporates, NGOs, nonprofits, academia, who all get around the table and innovate around new competitions and challenges we can launch to provide a more near-term set of solutions to the pandemic. So in that process, of course, we offered up the Data Collaborative as the means of which developing a number of these solutions. And we started going around the table to the different folks who were part of the Pandemic Alliance, many of whom are healthcare providers or sitting on high-value data assets, to say, how can we leverage the data that you're sitting on today to be able to enable the solution development? Our Data Collaborative provides a number of ML sandboxes per each competitor. They can pull in data sets. The Data Collaborative has a number of diverse open data sets. But then, of course, the hope was, let's bring in these very closed, private, high-value data sets, enable solution developers and domain experts to run inference on a combination of the public data sets that are already there, the private data sets that we acquired, and enable new solutions. These solutions could be mechanisms of doing new vaccine discovery, new ways to predict the spread of COVID, new ways to run mitigations around COVID-19. And we have a number of these different challenges and projects underway, which if you go to xprize.org, you'll see them. We face then the next challenge, though, which is many of those data sets that those healthcare providers in particular are sitting on are very locked away. They're very hesitant to open them up for both technical and policy reasons. So we then needed a way to assure them that there's a means of providing access to the data with, of course, not opening up yourself to new vulnerabilities. Remote computation being one of the key elements we were looking for. Happily, actually, Intel introduced us to the folks, the ACC folks at Microsoft, and highlighted that if there was a means of combining the essence of what is the Data Collaborative today, which is an open environment where innovators can use machine learning and data sciences to develop solutions on open data sets, with the ability to pull in private data sets enabled through ACC, the assumption is that we'll get the best of both worlds. We'll get these folks to unlock the data that is currently not being used to deliver, to drive new solution development. We'll allow them to interact between that data set and the other data sets that are on our Data Collaborative. So today, we've been working with Microsoft very closely on combining these two sets of technologies. We're pretty far down the path and eager to engage our audience and our set of competitors around leveraging this and really providing still a seamless way that solution development can occur, but doing it over very private, secure, highly valued data sets that today are not being used for solution development.
That's excellent. This is one of those use cases that we see resonating a ton in confidential computing, where customers are trying to solve this problem of sharing data. That data is so private and sensitive, and confidential computing is one of those technologies that can help solve that problem. And Andrew, it has been an absolute pleasure to work with you and your team. Looking forward to continued success here. Thank you so much. With that, I want to call out Steve from Novarad. Hi, Steve.
Hi. Yeah, my name is Dr. Steve Savetko from Novarad. Novarad is a leading provider of enterprise healthcare technologies in the world. And Personally, I've had 30 years of experience in medical imaging. My current focus has been using artificial intelligence for image enhancement and feature recognition and diagnostic purposes. Another focus of mine is also using augmented reality with medical images, aiding the surgeons, showing the patient images right over the patient. And for that, we use Microsoft HoloLens. I'm really grateful for this opportunity to sit on this panel and share my experience. Really the main challenge we experience is security. When we work with hospitals and imaging centers, we help them to manage petabytes of medical images along with the associated diagnostic findings. And that's very crucial data. There are some government regulations such as HIPAA, but as was alluded to earlier, the institutions are very protective of their data. And traditionally, most applications using that data ran on-site. And a new cloud computing application would require extensive vetting by every customer. As an example of this, one of those services NOVARAD offers is off-site encrypted data archiving, which provides the highest level of data integrity and security. But every time we go to implement this at a new customer, the questions are always different. It can take up to a year for that implementation to occur because of the security vetting process. So this does present a serious trade-off between ease of use and quality of patient care and sharing of patient data with security. And that, that's been a problem that we're always facing in this industry. The slide there shows a current solution that we've developed. It's called the NOVARAD COVID-19 AI Digital Assistant. What it does is it uses AI to look at chest CT scans and looks for COVID, visible artifacts that would show COVID-19. We currently have released this to limited pilot sites, and of course, we're soon going to release this worldwide, free for any medical institution that wants to use it. It runs in Azure. There's a small client service that runs on site, takes the medical images from the imaging scanner or the local hospital PACS system and anonymizes those images, upload those to the Azure cloud, where the AI processing is done. Now, locally on site, it prints out a paper form that has the patient ID, the patient name, the study, the exam date. It also includes a QR code that allows the patient to use, or the doctor, to use a smartphone and pull up the diagnostic results. Since the diagnostics results are based off the anonymized data that's in Azure Cloud, that diagnostic report doesn't have the patient name, but it has the same case number. It gives the probability of COVID-19. It also gives some key images of the patient's lungs, and that way you can see the extent of any lung damage. The accuracy of this solution is greater than 99% and can detect very subtle cases of COVID, and it can take minutes. You can get your results within 5 minutes. Where the nasal swab test can take days or a week to get your results back, and it can miss up to 40% of patients with COVID. So we feel like this could revolutionize COVID management across the world. Of course, not everyone gets CT scans, but most people that are admitted to the hospital for chest problems would get a CT scan, and then having this freely, instantly available, we feel like is game changing.
Thank you so much. This is awesome. Thank you so much for that, Steve. This is such innovation and so timely given the world that we are living in. Thank you for this. We are super excited to see you making progress here.
Thanks.
So with that, I'll switch to the panelists. We have a bunch of questions that we would like our panelists. Let me start with Sarah. Sarah, how can you help us understand how has working with Intel and Azure supported your solution development?
Yeah, sure. So when we set about the task of designing a cryptocurrency for mobile instant messaging, we knew it needs to be fast, it needs to be secure, and it needs to be private. No other cryptocurrency or payment offering meets those three criteria, which is why we had to create Mobilecoin. So we developed a suite of technology that enables mobile cryptocurrency payments without users ever having to sacrifice their security and hand over their keys to a third-party service. The design of our mobile payments infrastructure requires multiple horizontally scalable SGX enclave services, and Azure makes that possible, allowing us to use infrastructure tools like Kubernetes to seamlessly provision SGX nodes on demand. Running SGX at scale is difficult, as you know. In the beginning, we had to build everything from scratch, including custom memory allocation and bespoke provisioning software. At that point, sure, Mobilecoin could manually run SGX servers, but we also had a number of partners in the foundation and third-party node operators who were not as tech-savvy. So we were really lucky to find Microsoft as a partner who was capable of running SGX at scale. We'll soon be one of the largest consumer-facing SGX services, and we're thrilled to be capable of offering a payment system with the performance and privacy that users demand.
Thanks, Sarah. So as you mentioned in your intro, right, like you're dealing with really sensitive data, right, around financial instruments. So how is Intel SGX and confidential computing on Azure helping you meet these problems that you would run into around regulations and stuff?
Yeah, excellent question. And privacy and data protection are two of the core values of Mobilecoin. And these are also two areas where we are seeing more and more regulation. We see measures like the new privacy regulations in the EU, such as GDPR, as well as the right to be forgotten. And Mobilecoin puts user privacy first. And we want to put the control of data in the hands of the users. And so we're actually ahead of the curve on regulation on many fronts. And so how do we use SGX technology to be ahead of the curve on privacy regulation? We built the protocol from the ground up to ensure privacy at every layer. And SGX is a core part of the technology that enables this privacy. And it does it in multiple ways. First, SGX encrypted RAM enhances privacy by preventing the node operator or anyone with direct access to the machine from seeing the contents of the transactions or the process of validation. SGX also improves the consensus between the nodes who are working to agree on whether a transaction is valid. With remote attestation, it's harder for bad actors to join the network, and it's impossible for them to commit an invalid transaction. Enhanced consensus means that transactions can clear faster. SGX changes your assumptions about remote computing. Typically, your trusted computing base consists only of the machines that you control, and cloud machines are considered untrusted. This means that you assume that any data that you send to the cloud could be vulnerable. SGX extends the trusted computing base of a user's own devices to the trusted enclave that's running on the remote machine. For payments on mobile devices, this means we can provide confidential compute off of the device, enhancing performance and keeping the processing burden off of users' mobile phones. The Mobilecoin protocol practices defense in depth, and we carefully designed the system so that even in the event of an SGX compromise, it doesn't threaten user privacy or transaction integrity. For more details about how we did this, you can check out our tech talk titled Why SGX on YouTube.
Excellent. Thanks, Sarah. That was super awesome. And I think one of the key things that you said in there was even the node operator, your own people on staff, have no access to the data that is flowing through your servers as you normally would on a regular node in the cloud. So this is awesome, super awesome to see the innovations that you're doing. So with that, I'd like to call on Michael from Fireblocks. Michael, can you help us understand how your journey has been with Azure and Intel and kind of making your solution shine on confidential computing?
Yeah, sure. So I guess similar to the way that Sarah described it, I think that the Intel SGX was sort of part of our solution from the very early design phases. And I think that as part of our technology stack, not only that we focusing on basically the privacy or the private aspects of making sure that the information is not exposed outside, but actually one of the key elements that are important for us is the ability to guarantee execution, right? So to make sure that we cannot be exposed to either insiders or hackers that even were able to compromise or to somehow break into the actual workload to modify the execution of the program. And that basically helped us to create, I would say, two specific technologies. The first one was the ability to secure what we call secure the custody or to secure the private key management. And the second one was actually to create attestation around communication and making sure that the transactions are moving end to end and essentially creating a secure network. And that's part of our IP. So that what basically help us from a Intel SGX standpoint. But I think the next step really was to working with Microsoft Azure, because we really had to scale the solution, right? So I mentioned that our business is actually scaling fairly rapidly on the basis of just our ecosystem expanding, and we had to basically find a really strong partner that is also very that our customers are financial institutions. Some of them are very big institutions, are comfortable with. So Microsoft, of course, is a brand name in the financial space, and a lot of our customers, they have a very strong relationship with Microsoft, and they're very keen to basically deploy and leverage Azure Confidential Cloud Computing as part of the deployment. It's very natural for them. Mm-hmm. And working with Microsoft, we really were able to leverage that. I think that over the last couple of months, we were able to funnel over 30 customers that I think deployed workloads with our solution on Azure Confidential Cloud Computing, and it's just been an awesome experience.
Excellent. Thanks so much, Michael. That sounds pretty awesome. Thank you. So with that, let me call on Steve from Novorad, and the same question to Andrew following that, which is you had existing solutions that would benefit from a higher level of security, as you mentioned in your intro. So how do you see confidential computing or Intel SGX help in you achieving your business goals?
Thanks. When we found out about the Intel SGX and the Azure Confidential Computing, I immediately saw the usefulness in our development. As I described earlier, the AI models we developed for our COVID-19 project, they represent a huge investment in technical development, patient data, and the expertise of doctors who've spent countless hours labeling and highlighting COVID on these tens of thousands of images. We'd like to keep that, that data, those models secure. But more than that, we had to go through kind of this anonymization step where we anonymized and stripped a lot of the protected health information from these images before uploading them to Azure. We did that so that in the case of COVID-19, we could deploy this, rapidly everywhere without concerns from the medical institutions. But it's, now we don't have that luxury with other products that we are currently developing. And for us to be able to tell these customers that their medical data is good when it leaves their institution and is uploaded, it's encrypted, and none of our employees, none of Microsoft employees have access to that data. Mm-hmm. Our processes don't have access to that data. Just the that signed code that is running in the SGX environment can use and we don't even have the limited data. We'll have the full medical data to make our inferencing and our diagnosis. So it's more data that we can use. It's more secure, and there's really no drawbacks to it. Yep. And I feel like it would be quicker to deploy and an easier sell for our customers. And in turn, it would make the healthcare experience for patients. It would speed it up and give better diagnosis and better healthcare.
Excellent. Thanks so much. That's awesome, Steve. This is great. Hey, Andrew, same question for you for X Prize. What are your thoughts on confidential computing achieve that higher level of security for your workload?
Yeah, I mean, in a nutshell, we've built a platform for a collaboration around data. We built an ecosystem with our Pandemic Alliance where different providers, including healthcare providers, could bring their data to the table. But now that we have to take it to that next step, and the next step is really unlocking, getting those parties confident that they can unlock that data and allow a community of competitors who they don't know build models and run inference on that data and develop solutions around it. It's no small hurdle. It's as much a political and a organizational issue as it is technical. But our hope with confidential computing is that at least it check marks the technical box. Our hope also with further momentum is that it builds that confidence across the entire healthcare ecosystem.
Excellent, excellent. Thanks so much, Andrew. This is great. We are really excited about our partnership here. So with that, I think I'd like to bring this to a close. Again, I'd like to thank everyone for taking the time to watch this. As you can see from the different use cases we outlined here, confidential computing is the approach that you can take today to protect your data and use, get that higher level of security posture, really know who has access to your code, what are you running when you're running it in the cloud. So with that, we'd like to call it to a close, but we have a few call to actions for you. We have an Ignite session where we talk about the new developments for protecting your data with Azure Confidential Computing. I encourage you to check it out. I also encourage you to check out our website, the two websites down there, the one which has the Azure CC, that is the homepage for confidential computing on the azure.com website. You can go there to get a link to our blogs, our documentations, case studies, and so on. And similarly, I encourage you to check out the intel.com/trustsgx website, where you can learn a lot more about how SGX can help you elevate your security posture and provide better, more secure solutions for your products and your customers. So with that, I again want to thank our panelists. This has been awesome. I am so excited with the amount of innovation and progress that we've been doing together. And I'd like to thank the people who tuned in. Thanks, everyone. Take care.